we're at IBS 2026. We're at the Panasonic booth, and I'm here with Ken Nelson, and he's going to talk to you guys about the ERVs. As we're walking around and looking at all the booths here, everybody's trying to figure out how to build the tightest home envelope they could figure out. This way there's no energy leaving the house or making the house the most efficient, but that creates a problem, and Ken's going to talk about that.
So the challenge then becomes, as humans, we need fresh air, right? So if I leave all that air in the house and there's no way to move, I just wind up living in the soup that our own people generate, right?
Yeah.
So what we've come up with is the codes and standards have come up with a value that they want air changes to occur. So, and you can do that in one of three ways. There's a exhaust only, a supply only, and a balance strategy.
Open the window, right? So you'll hear a lot of people say just like, well, open the window.
So here's the challenge with open the window. We know that air only moves when there's a pressure difference. So if it's 70 degrees outside, 70 degrees inside, there's no movement. So technically, you don't get any air difference. So what we want to do is we want to mechanically move air in and take air out. Predictable, I always call this predictable and uneventful. I don't want the wind to have to blow. I don't want to have temperature difference.
Yeah.
So the ERV, the energy recovery ventilator, essentially brings air in from the outside and it runs it through a core assembly and takes air from the inside and runs it through, again, the core assembly. And now I can get fresh air, so in such a way that you're not taking an energy penalty for that ventilation air coming in. Because, for example, if you live in a cold climate where it's 30 degrees outside, 70 degrees inside, that's a 40-degree delta. No one wants that 40-degree air just to be plowing into it.
We actually have something right here that this is how it actually works, correct?
So this is our core material. And what happens in the core is you have a permeable material, and then the air flows across on one side, right?
Oh, you can see it right through here.
Yeah.
Okay.
And then on the other side, you'll see this is the other side, so it would line up like this. And then the air is going to go the other direction. This air is going to come in under here. On this side, it comes in. So the air doesn't exchange, doesn't touch.
Yeah.
However, this permeable material allows water vapor, or actually it's the hydrogen and the oxygen molecule to push across. It decouples, pushes across, recouples. But it takes that temperature with it and moisture load. So what we do to make this even more efficient is I'm going to speed this airflow up, because as a builder, we all know vapor drive, right? Vapor drive is our nemesis. We work very, very hard to stop vapor drive, which is our air leakage in and out of the house. So this, we encourage vapor drive. In fact, we're going to encourage it in such a way, we add air pressure from the fan motor into this, and that is an exponential amount of vapor drive then that occurs. That's how I can capture all these efficiencies with ERV. So I can capture heat and cooling, or I can capture moisture, or reject moisture.
So I guess the overall point of all of this is that the air that you have spent money to warm up, you're not just opening the window and blowing it out of the house.
Exactly.
Or the air that you spent money to cool off, you're not just blowing it out. Does the size of your ERV matter? And we're seeing so many examples here, and I just want to kind of hear what's the proper use or the sizing for an ERV.
Size and configuration, right? So sizing, what we look at is the ASHRAE standard for continuous ventilation. And while there's a number of ways to calculate it, I'll tell you a round number would be about 30 CFM per 1,000 square feet.
Okay.
Bear in mind that almost all ERVs are scalable up and down the continuum. So I can go as high as 200 CFM, I can go as low as 30 CFM. So I can set these at whatever value is required for your project. So if you have a 2,000 square foot house, you need 60 CFM. Literally, I turn the button, turn the dials, I've got 60 CFM balance. And then if I want a boost function, I can add the boost control and it'll go to boost position. But the other component to this is configuration. As a builder, I don't want you to have to rebuild your entire house to accommodate whatever you need. Let's say you're putting your mechanical room downstairs, you might want a top port. If you're putting your mechanical room upstairs, you might want side ports. If you're doing mechanical room, these narrow applications work really well. If you're just going to hang it over the utility room and put it on a J-rail,
what about
I like these balanced homes.
This little
Whisper Comfort is one of my favorites, because We use this in the multifamily world because it goes right into the ceiling.
Yeah.
It's a ceiling cassette style. So this application, if I have a small footprint, because I'm only going to go 20 to 60 CFM.
Yeah.
So as I said, 30 CFM per thousand. So I can neck this down to a smaller.
So this is as simplest as it gets. If you basically want to just start to dabble with ERVs, this is kind of where you would start.
We see this in like remodels where you add a media room or an ADU or something along those lines.
Good point.
Put that in there, easy cheesy.
Yeah.
If you have a basement that's musty smelling, you can put that in and create a neutral air barrier right there. So now that mustiness is diluted and diffused, but it also doesn't reach the house, right? It doesn't get upstairs. So this is probably my number one selling application, and it's lowest cost, easiest to install, and hardly any penetration.
So just be mindful that if you guys are building a brand new house, most areas now in the United States will require some type of mechanical ventilation.
Correct.
So you're going to have to do some research on your ERVs and figure out the proper sizing of it and kind of what fits your situation. But plan ahead, because then it's way easier to deal with all of this stuff.
Absolutely. And the ERV is going to give you a better HERS score, a better performance pathway score. It's going to allow you, if your home buyer wants to add another 6 inches of window, it might allow you to that without having to go through a ton of hoops and challenges to get that done. The ERV business has probably been the biggest increase in all of the ventilation strategies that are in the last 3 years.
Everybody's trying to figure out how to build the tightest, lowest, the most energy efficient home, which just means nothing leaves the house or comes into the house.
And we want to encourage that, right?
Yeah.
We want our occupants to have a low cost of life, right? So that they can live. And everything today is more expensive. So if we could help with that heating and cooling by minimizing that cost and help with their health by minimizing the pollens and stuff that get into the house, this is a great solution.
That's awesome. Well, thank you, Ken.
Misha,
I appreciate it.
I appreciate you coming
I hope you guys learned something about Panasonic ERVs.
Thank you.